Hello. This is going to be a little video tour of the calorimetry apparatus, and this is called a bond calorimeter. I'm going to take the lid off, and it has a stir, and it has a thermometer, and so it's convenient to be able to set it on this stand, so you don't have to try to figure out how to lay it down on the lab bench. And then inside this insulated container, we have a bucket, and in there we have this stainless steel container, which is called a bomb. It's not intended to be a bomb, but it is called a bomb. And I'm using this device for lifting it out. Normally this would be in water, and we have to find the location of the holes. So it's setting on a pedestal inside this bucket, and I'm going to connect this lifting device on the edges of the lid, and then if it's secure, it will just lift this right out of the bucket, and that way it minimizes the amount of water that has to be touched with your hands if you're using this lifting device. If it's been submerged in water, you can pour a little bit of water out, and so there are going to be some water that we put in this bucket. So here's our bomb, and it consists of a collar, and if I take this collar off, there's a lid. So I work this lid off. You have to kind of wiggle it a little bit, and you can see this is a stainless steel container. It's like ½ inch thick stainless steel, all the way around. And we have an O-ring that goes around this this groove, and over time these O-rings can get a little bit old, and so we'll watch. Your lab guide will give you some clues to watch for whether there's a little air leak in your system, and it's easy to replace O-rings. So one thing to look out for. So in this lid we have a wire for a sample, and so I can set the lid in this other holder, and we're going to end up putting a small sample of about 1 gram in the first round, the first experience with the bond calorimeter. It's going to be a reference material, benzoic acid, with a known combustion energy. And so we're going to put our sample pan on a mass balance, and that's right behind us in this particular example, and it's across the aisle for the other setup for the bond calorimeter. And so we'll go tare this on the balance, and we'll measure a pellet of benzoic acid in this pan. So we want to know that mass as accurately as we can. And then you're going to use your scissors and trim off 10 centimeters of this fuse wire. In this fuse wire, you'll get a little bit of this fuse wire. It's probably too hard to see it on the video, but your little card allows you to measure 10 centimeters. And once you have this fuse wire, you're going to connect it onto the electrical holders on either side of this support for the pan. And so for one example, you're going to lift up these holders, these securing devices, and slip the wire through and then run it down on there. So you can see this a little better here's one of these parts, and they slide up and down, and there's a little hole, and I slid the wire through there, shoved that down on it, and I've got a good connection. And then your guide will give you some guidance, but you want this wire to come into the cup, not touch the pan, and then, but do touch your sample, your benzoic acid, and run over to the other side and connect to the other side. So we're going to run current through these two, and that's going to vaporize the wire, which is going to ignite the benzoic acid. Okay, so once your wire is set in there, you're going to put your lid on there securely. You want to be sure the O-ring is in good place, not crimped as you place it in there. You put your collar on. Now on the top of the lid, there's the two places where we're going to put the electrodes. There's a place where we're going to add oxygen, and then there's a release valve. So the valves are always righty-tighty, so you do clockwise close. And I can turn this clockwise and feel that it kind of engages. And all I need is a little gentle kind of snugness to that to close that valve. And now we're going to go and have a look at the oxygen cylinder. So I'm going to take you over there. And I'm just going to kind of go on the other side and see that what you're looking at makes sense. Okay? And now what we want to do is we want to put oxygen in our bomb. So we've loaded the benzoic acid, get the wire in there, so it's going to ignite the chemical reaction. We want some oxygen. So this is our oxygen cylinder. This is the main valve. So clockwise close, this is a closed valve, I can test it. If I open it up, I can see that this is indicating that we've got a decent amount of pressure in here. Right now this is reading 1500 PSI. So we have a good supply for our CHEM lab. And I'm going to close that off. This is the gas regulator that we'll have in place of this one when people are ready tomorrow already. And so we're going to see about 1500 PSI on the small gauge. That's the high pressure. And then this gauge is the one that we're going to watch to see what we get for the lower pressure. And this fitting is what slips over the post on the bomb. So that slips on there, and that's a one-way valve. So when we generate a high pressure on this side, we'll have oxygen flowing in, and once we've made the pressure inside higher than outside, then it will be sealed. So what we're going to do is once we place that on the post, we're going to open up this valve, and we're going to open it up to get about 10 atmospheres and close it. Now that means not that there's now not just 1 atmosphere of air inside our bomb from when we closed it up, but we've also added at least 9 atmospheres of oxygen from the gas cylinder. So I'm going to open up the release valve and let that out. And what that does is now we have made our nitrogen concentration inside the bomb 10 times less. So I'm going to do it a second time, open it up, and then close it when it gets to 10 atmospheres, and let that out. And so now I've reduced nitrogen from 80% of what's in the bomb, first time to 8%, now to 0.8%. And so now nitrogen is a small enough amount in here that we don't have to worry about some additional kinds of combustion reactions that can occur with oxygen and nitrogen when the temperature gets high inside our bomb. So the first two steps of going to 10, releasing, going to 10, releasing is just simply to flush out the nitrogen. You could do a third if you wanted to make nitrogen even smaller. And then we open up the valve and get it to our target, which is 30 atmospheres, and that's filling up the bomb. Now, once you have 30 atmospheres, you just lift this off the post, and now our bomb is filled with oxygen. So it's very easy to use. This is a compressed gas cylinder, so we do have to be paying attention to some safety. This we do not want to fall over in the lab because it can basically be quite dangerous to have some damage occur to the valve under very high pressure. So it is two straps locking it to the wall. It can't move. And at the end of the lab, I will be probably checking the main valve to be sure that's closed so we don't lose nitrogen overnight through leaking. But that's how we use the oxygen. So now our bomb is ready to go. So let's go back over here. And let me check out the view. There we go. Okay, so in our bucket, we want to put a certain amount of water, and we're going to be watching the temperature of that water increase because some energy is going to be released by the chemical reaction. That's going to increase the temperature inside the bomb. That temperature has to warm up this entire stainless steel container, and then it warms up the water surrounding it. So we want to precisely know how much water we put in. And what we've done for COVID conditions is we've measured out exactly 1,000 grams of water in this bottle. That's been done for you. And you're going to need 2 of these to fill your bucket. So to do this with the least amount of uncertainty, we're going to pour the entire amount of the water in here and then have it upside down and really kind of shake out as much of the droplets as you can. And we're going to call that a quantitative transfer. And you do that twice for every time you run a trial. So we put water in the bucket, exactly 2 kilograms to within the uncertainty of pouring water out of these 2 bottles that have already been set to be exactly 1 liter or 1,000 grams. So that's our scheme. That means you don't have to go over to the sink. You don't have to use another balance to weigh those things out. We're just going to pour water in from these 2 1-liter bottles. Once you have water in there, you're going to we've got our bomb completely prepared, so it has benzoic acid. It's got a wire that touches only the benzoic acid. It's a good tight connection. If you're uncertain about conductivity, I can give a conductivity meter and we can check that. Sometimes that is a little bit of a question. But if you're confident in your connection of those wires, so you've got a full circuit, we're going to take this and put it in the water. We're going to observe. There's always going to be a few air bubbles that get trapped by the rim, and those will bubble a little bit. But then as long as that settles down and there's no continuous bubbling, then we feel like our seals are good in our bomb. We're going to put our bucket in here. There's a few posts down there to locate it very precisely. We're going to slide these 2 connections into through the water into those connections. And then we're going to put our lid on. It has one place where it sort of fits nicely. This is a good insulation. Our belt can come across, and you can see if we turn that on, we can start to circulate the water in there. So the water will circulate inside the bomb, and our temperature sensor will be able to monitor that temperature over time. So that comes to a vernier device, which will be by USB connected, ideally to your own laptop, if you are able to bring one to the lab and have Logger Pro loaded on it. Ideally, that's prior to coming to lab. So all you have to do is plug your USB in there, and then when you launch Logger Pro, it should recognize the temperature sensor. There's a few notes in the lab guide about making sure the temperature sensor shows the nearest hundredth of a degree, and that the timing is over a reasonable period of time, so that it doesn't stop before you're done recording data. The last thing is you need to ignite your sample, and that's done using this ignition unit. So this is one of the things that you'll have to share with the other person working across the bench. We have chosen to put a little hand sanitizer available in the lab right here by the ignition unit. So once you've made arrangements to connect those things, you can use your hand sanitizer. It's the most practical way to do that. These two wires can come onto the common and the 10 centimeter posts on the ignition unit. And once those are connected and your Logger Pro is running for a little while to establish a nice stable baseline, you're going to press this button, and there should be a short half-second red flash which will indicate that current flowed in the wire. That current flow should ignite the sample that you have inside the bomb. And as long as we keep that sample to about 1 gram or less, then the safety parameter of the bomb will mean that it will not fail. And so once you've ignited that, you can put your ignition unit back in the center. You can hand sanitize. And then you're just watching to find the temperature rise, and you're looking for a maximum temperature. So you establish a baseline, that's your initial temperature. You find a maximum temperature. I always recommend going a little further so you clearly see it starting to fall. It takes a few minutes. And then that difference between the initial temperature and that maximum temperature is your delta T. So once that's done, you can take your system apart. You're going to fish your bomb right out of the water. I'm going to find the other part. There we go. This guy out, there'll be some water. And you won't be able to take the lid off. There'll be a high pressure. You have to open the valve to let the air out, the high pressure. There's an excess of oxygen, so there'll always be a little air pressure in there. You release that, and then you can open up your system and you can clean it out and get ready for the next run. So that's kind of taking you a full tour of how you do one apparatus. So for COVID, I'm planning that every partner is able to do 2 runs. And the first lab period is always going to be just running benzoic acid. So it's very straightforward. And in fact, it's kind of a measure of your consistency of being able to do repeated measurements. You compared also to your partners. And that'll be a very interesting thing to look at. So everybody in the first lab is going to do 2 runs of benzoic acid. And then I'm going to do another video introduction for the second week where we're going to look at some other samples. And there the goal is to learn something about strain energy in some organic samples that we can load up into our bomb and combust those, and then determine what the combustion energy is for that. Okay, so that's our introduction for bomb calorimetry.